Hello, calculus fans. Okay, so let's try evaluating this integral of x squared cosine x dx. And we'll integrate this by parts also. We're going to choose u equal x squared and dv to be equal to cosine x dx. We're going to talk later on about how we make this choice of u and dv. For now, let's just worry about the mechanics of doing integration by parts. Once we have u, we'll take a derivative to get du. So du is 2x dx. By the way, don't forget to put the dx in there. We need that in our integration by parts. And then if we have dv equals cosine x dx, then we compute an antiderivative of that to get v equals sine x. That's an antiderivative of dv. Again, we're leaving off the plus c here. Okay, so now we're ready to write out what this integral is using the integration by parts formula. So that's uv minus integral of v du. So here is uv, which we see here, and then we have v du, and we see that here, the integral of that. All right, now to evaluate the integral that we came up with here, we're going to integrate by parts one more time. So now let's worry about evaluating this integral, then we'll piece it all back together. Okay, so for that integral, we're going to do u equals 2x, dv equals sine x dx. So du is 2, that's the derivative of 2x, don't forget the dx. And then v is negative cosine x, that's for an antiderivative of sine x dx. Alright, so now when we piece these together, we've got our original solution that we came up with, x squared sine x minus the integral of 2x sine x. And so now we've got uv, so here is uv, and then that's where we put it together here, minus the integral of v du, and that's where we see here. Alright, watch out for all these minus signs, there's a lot of them floating around. So if we clean this up, this is what we get. And now this last integral that we have, the integral of 2 cosine x dx, well, that one's easy. And we just get this. And now, again, here's the point at which we're going to put in that plus c. So in this case, we had to integrate by parts twice. The first one made it a little bit simpler, but not simple enough to be able to evaluate directly. Then we did parts one more time to finish the problem. Okay, that's all for now.